Hi, Year 13. This video is showing you how you can use implicit differentiation to prove or obtain a derivative that's awkward. You did this in your homework, so it's just in case you struggled with that. All right, so given that y is 3 to the power of x, show that dy by dx is 3 to the x natural log x. So the only exponential you know how to differentiate is e to the x, and you get e to the x, don't you? So if you the clue is kind of in the answer, it's got a natural log in there. So let's take natural logs of both sides first of all. So we've got natural log of y is going to equal natural log of 3 to the x, which we could write natural log y is x natural log 3, bringing the power down. Now this is simply a constant. So because 3 is a constant, then natural log 3 is also just a constant, just a number. Okay? Right, so we're going to use implicit differentiation. Now we know that when we differentiate natural log, then we usually get 1 over the thing. So we get 1 over y. Now because we're differentiating with respect to x, and this is y, we need to multiply by dy by dx using the chain rule. So then the next part, imagine that just said 6x. If you're differentiating 6x, you just get 6, because 6 is a constant. And it's the same here. If we're differentiating x times natural log 3, we're just going to get natural log 3. Oops. So I'll just, write that bit better. So d by dx of x times natural log 3 is just going to be natural log 3. Right, and then we can tidy that up. So dy by dx will be y times natural log 3, but we know that y is 3 to the x. So it's 3 to the x natural log 3, which is what we wanted. So pause the video in a second and have a go at doing the same, but we're using 2 to the x instead, just to check you're confident. Okay, so here is the solution for that one. Okay. So in general, you could just use this result. If you're not asked to prove it, you can just quote it. So whatever the base number is, you have that as the natural log afterwards. Okay, so if you're proving it, you would use exactly the same approach. So let's have y is a to the x. So then natural log y is going to be x natural log a. And if we differentiate implicitly, we get 1 over y. Dy by dx is natural log a. And then rearranging. And finally, replacing y is, so that's a to the x natural log a. And that approach is also used in further maths when you're finding derivatives of some of the trig inverse functions.